Hey guys, what's up everyone? Welcome or welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and of course in today's video we're going to be looking at the introduction to the Pythagorean theorem. I'm actually not going to be proving the Pythagorean theorem to you, but in fact I'm just going to be doing a video that is related to the application of the theorem to a few basic questions. This is a part one of a 2 or possibly 3-part video where I'm going to be looking at some more advanced questions as it relates to the application of the Pythagorean theorem in more complicated diagrams, or diagrams that appear to be a little bit more complicated. All right, but of course, if this is the first time here on the channel, AP3X Institute appeals and provides content to students following the curriculum of the EDEXCEL exams, SEA, CCSLC, CSEC, CAPE, ADMATH, and college courses. That is the content to which I provide students with. All right, so if this is the first time here on the channel and you're a student currently struggling or need to catch up with your classes, or you want to stay ahead of your classes, you definitely want to smash that subscribe button below, and of course make sure that the bell notification is turned on, because I do post videos on a weekly basis where it can be quite useful for revision purposes or going ahead of your class. And if you're getting any sort of value from the content that I have been posting on the channel so far, of course consider smashing the like button and getting the content out to a more wider audience. Right, so without further ado, let's jump right into the lesson for today. Now, as you can see here on screen, we're going to be looking at the application of the Pythagorean theorem. Now, the first thing that we need to understand about the Pythagorean theorem is one of the criteria of this theorem is that it's only applicable in a right triangle. Now, a right triangle, as most of you guys would have already known, it's a triangle consisting of 2 acute angles and 1 90-degree angle. And this 90-degree angle is usually indicated, as you can see here, by a little box in the corner here. Okay, so this is the indicator that lets you know that the triangle that you're observing is a right triangle. Please bear in mind that the right angle triangle is a part of 4 members. That is the scalene, isosceles, equilateral, and of course the right triangle. A very special triangle at that. So you definitely want to make certain that you know all the properties of this particular figure. All right, now Pythagoras came up with a very interesting formula, and I'm not going to be doing a video on its proof, but I can let you know that this formula is quite useful in many aspects of math. Now, what is this formula here? Before we get into that, let's look at the right triangle. And with the right triangle, you will find that most of the time we name the lengths of the sides with lowercase letters. All right, we name the sides with lowercase letters. So as you can see here, for my particular explanation, I have labeled the slant side here with the variable c, and I've labeled the vertical side here A and the horizontal side here B. Now I can interchange the letters if I want to, but interchanging the letters would mean you would also have to interchange the letters being used in the formula. So to ensure that we have a level of consistency, we just, well, I particularly just stick with naming the slant side here C and the other 2 sides A and B. Now, just to be a little bit more specific here, as we scroll up, we're going to be looking at this diagram here where we are now seeing that this slant side here is known as the hypotenuse. The slant side here is known as the hypotenuse, which we usually label with the letter H. And that particular side is usually identified easily because it always appears opposite to the 90-degree angle. So you cannot miss that side. So whenever you're going to be doing questions as it relates to when the diagram has been orientated or the orientation of the diagram has been changed, then one side is that you will never be able to forget, or you shouldn't forget, is that it's the hypotenuse. It always faces the 90-degree angle. Now, the other two sides are known as the perpendicular and the base side. Now, as we go further into the application of trigonometry, then you're going to find that the perpendicular side and the base side will be known interchangeably as the opposite and the adjacent. Now, as it relates to which one is the opposite and which one is the adjacent, that is going to be heavily dependent upon the reference angle. And the reference angle here can either be at the bottom as indicated in this particular diagram, or it can possibly be at the top here, where these two angles are known as the reference angle. All right, reference angle. So we're not going to be focusing on which one is the opposite and which one is the adjacent, because as it relates to Pythagorean theorem, we don't need an angle to apply this formula. So we're going to be ignoring this for now. In part 3 is where we're going to be looking at which one is and isn't, and how will we know what to assign to what. All right, but for now, for the Pythagorean theorem, the slant side is known as the hypotenuse, and the vertical side is known as the perpendicular, and the horizontal side is known as the base. All right, let's jump into another aspect of this. Now, as you can see here, I am showing you now the Pythagorean formula, and the formula as seen here on screen is a squared plus b squared is equal to c squared. All right, and as you can see here that I have again labeled my slant side here with the letter C and the other two sides A and B. So basically, without explaining the proof of the Pythagorean formula, in its simplest form, we are saying that should you square the length of the hypotenuse, then it's going to be exactly equivalent to the sum of the squares on the other two sides. So if I were to square the short side here, and I would square this, well, if I was to square the perpendicular side here, and I was to square the horizontal side here and add both sides, it's going to be exactly equivalent to if I were to square the hypotenuse side here. So this is the formula. Now, typically, usually, you're going to find me labeling the formula the other direction. I prefer writing the c square at the front and the a square plus b square to the right side, right? Because particularly I like to read my answer in this direction. All right, but no special reason, you can use it as it is here. All right, so let's get into just applying the formula, just looking at a few working out, and we're going to be looking at this particular question here, where this particular triangle is in fact a triangle that belongs to the family of the Pythagorean triples. All right, but let's look at it here. Now, going forward, I mean, looking at this video here, clearly we're going to be using the Pythagorean theorem to get the value of the unknown variable here, or the unknown side. But going forward, there is actually criterias that must be met, because when you learn more than one formulas, then it becomes a little blurry for students as it relates to which formula to use when and where. So particularly when it comes to the Pythagorean formula, I have come up with 3 criteria that every student must ensure is met before you can make a decision as it relates to the Pythagorean formula. And those criteria are: 1, you must be looking or you must be searching for an unknown side. Number 2, you must be applying the formula in a right-angled triangle. And 3, you must be given 2 of its sides. You must be given 2 of its sides. Now, provided that those 3 criteria have been met, then we can go right ahead here and apply the formula. So it would have been, in this case here, the formula would have been c squared, as instructed here, is equal to a squared plus b squared. Now, if that is the formula, then we can go ahead and insert the values accordingly. So in this case here, according to the diagram here, we have already labeled our hypotenuse side C, and I strongly recommend that we stick to that routine because it gives consistency. Always label your hypotenuse side C. I find that a few students make the error by saying that the unknown side is always C. Not in this case. The unknown side can be C, A, or B, but what stays consistent is that the hypotenuse side should be always labeled C, if it is that you're using the formula this way. So C in this case here is going to be equal to x squared. So we're going to have x squared is equal to a squared, which is going to be 6 squared, plus b squared is 8 squared. So therefore we can say that x squared is equal to 36 plus 64, and then you'll see here that x squared is equal to 100. Now, in order to remove the square away from the x, we're going to have to take the square root of both sides. So you're going to find that x squared, or the square root of x squared, is going to be equal to the square root of 100. So you'll find here that the square root will cancel the square. So you end up with x being equal to 10. In this case, we could say units or centimeter or whatever the case is. But since there isn't any unit of measurement, we just simply say that x is equal to 10. All right? And that would be one example in its application. So this is one of 2 scenarios in which the Pythagorean theorem is going to be applicable. Let's go right ahead and go over to example number 2. So in example number 2 here, we're once again looking at a diagram. All right, and let us check to see if the criteria for Pythagorean theorem has been met. It is in fact a right triangle that we're dealing with. So criteria number 1 has been met. We are in fact looking for an unknown side, which is labeled with the variable b, and we have been given 2 of its sides. All right, now it doesn't matter which 2 sides are given. You could be given 2 legs, or you could be given a leg and the hypotenuse. But once you're given 2 sides, then we know the Pythagorean theorem is what we have to do here. So now, once again, c squared is going to be equal to a squared plus b squared. And so therefore, once again, c is going to represent the length of the hypotenuse. Remember, c is not the unknown side. I find a lot of students tend to run away with that information. So let's kill that from now. C represents the hypotenuse. So 17 squared here is going to be equal to C, and A and B are going to be the legs. Now, since as we are already using B to represent one of our unknown side, we can just stick with letting this B in the formula represent the B that is representing the unknown side here. So this would be 15 squared plus easily B squared. All right. Now, once you have your calculators out, ensure that you verify 17 squared should be equal to 289 and 15 squared should be equal to 225, and that's going to be now added to B squared. All right. Now, we should be very good at solving linear equations. All right. That should be a prerequisite skill for Pythagorean theorem, because you're going to find a lot of the times that you're going to have to do a lot of solving. All right. Now, I have a link that is in the description to a video that I did as it relates to solving equations. So you definitely want to check that out if you're having some, or if solve equations is a weakness of yours. You definitely need to learn how to solve. If it's even very simple equations like this one, it is at least a start. So you don't want to struggle with that aspect. Let's just transpose here the 225. So we're going to have 289 take away 225, and that's going to be equal to B squared. Now, if we go right ahead and we subtract these two, you'll find that the answer is 64, and that's going to be equal to B squared. So therefore then, if we want to find the variable B by removing the square, we would find the square root of both sides, and that's the square root of 64. So cancel. B is equal to, now because this is a realistic example, so to speak, then usually whenever you find the square root, you are supposed to say that the answer is plus or minus the result. Square root of 64 is 8. Now, because we are finding the length of an unknown side, we know that a length cannot be negative. So naturally, we would never consider the fact that the answer could be negative 8, because length cannot be negative. But realistically, negative 8 squared is 64, and positive 8 squared is 64. So the answer is in fact plus or minus 8, but we only use the positive result because we are finding a length. All right, so hopefully you guys got that. Now, so far, if you're getting some sort of value, ensure that you smash that like button, and do not forget to share this to your study groups, friends, other students that are across the Caribbean, so that they too can get some clarity on this very, very interesting concept in math known as the Pythagorean theorem. Now, we're going to skip across to a few example questions here. All right, and let us not limit our potential to the fact that Pythagorean theorem provides answers that are going to come out as nicely as you'd like them to come out. That's not going to be the case. There are going to be occasions where you can be provided with the dimensions of the sides in a decimal value, or the result can come out as a decimal value. Now, depending on the level student you are, you should already know that the answer can be almost anything. Pythagorean theorem can get really, really advanced later on, but for now, this is just an introduction video for students doing exams such as this level. So here we go. We're going to have a look at example number 1, or question number 1 here. Now, you see I have some arrows here pointing, and the reason for those arrows is just to ensure that you guys remember that C represents the hypotenuse. Because we are using the formula C squared is equal to A squared plus B squared, always remember that C represents the hypotenuse. So as you're looking at these diagrams now, the orientation of the right angle triangle has been changed. So naturally, you don't want to construct in your mind that the hypotenuse side is the side to the left or to the right or at the top or at the bottom. As the orientation changes, then C follows the orientation. So for this particular diagram here, you can see that I've pointed an arrow from the 90 degree towards this side and I've labeled it C. Same thing here, pointed an arrow from the 90 degree angle here towards this side. So this side is going to be C. Same thing here, and here. So C again represents the length of the hypotenuse. A and B naturally subsequently would represent the other two sides respectively. So therefore, if we take a look at example number 1 here and we write down our formula, C squared is equal to A squared plus B squared, we can be sure that we are using the correct formula because we have gone through the process repetitively of meeting the criteria. Is it a right angle triangle? Check. Are we finding an unknown side? Check. Are we given two sides? Check. So once those three criteria have been met, we can check and know that the Pythagorean formula is the formula to our aid. So in this case here, example question number 1, C squared will become X squared. A and B are going to be 15. Pardon me, that's not supposed to be a plus. That's supposed to be an equal sign. So that's going to be 15 squared plus 8 squared. So X squared, ensure that you have your calculator at hand working with me. Don't just be watching the video. Work with me and calculate as we go along. 225 plus 64, and if we calculate, we will find that the result here works out to be 289. So therefore X squared, or I should say the square root of both sides, so that's the square root of X squared, is going to be equal to the square root of 289. So if we cancel the square with the square root, we'll find that X works out to be the positive result of 289, which in this case is 17 centimeter, because the unit of measurement for this particular diagram is centimeter. Alright, beautiful. Let's move on to example number 3. We're going to go across in this direction here. So once again, let us try to meet the criteria. Is it a right angle triangle? Check. Are we given two sides? Check. Are we looking for an unknown side? Check. Now, when you consistently do this as a student, you're going to find after a while, as you look at a right angle triangle, it will immediately come off to you that the Pythagorean theorem is the formula to aid. So just to build a level of consistency and to build a level of focus and to ensure that the concept has been drilled inside you, you keep doing this until you don't have to do it anymore. So I've done it already. I already established that C squared is equal to A squared plus B squared is going to be to my aid. So once again here, I'm going to find that C represents my well, in this case, C represents my unknown side, but naturally C represents my hypotenuse, which in this case is X. So X squared, once again, like the previous example, is going to be equal to 6.5 squared plus 10.2 squared. So if we check on our calculator, make sure that you have your calculators out, guys. All right. It's going to be 6.5 squared. That works out to be 42.25. And that's going to be added to 10.2 squared, which works out to be 104.04. And if we were to go ahead and add 42.25 to that result, we'll find that x squared is equal to 146.29. And naturally, if we take the square root of both sides, we'll find that x, let's see here, 146.29, we're going to find that the square root cancels the square, so x is therefore equal to 12.95. So we're going to take 12.09. If we wanted to round it off to one decimal place, it would be approximately equal to 12.1. Alright, so hopefully you guys got that and you are clear. Alright, now what I'd like for you guys to do for me here is actually go ahead and work out question number 2 and 3, or pardon me, I want you guys to work out for me as an assignment question 5 and 4, and I'm going to do question 2 here as an example, because I haven't really done an example where I'm finding a leg. So I don't want to leave this video here without working a side where I'm finding a leg. In fact, I want you guys to work out question 5 and question 2, and I'm going to end this video by working question 4. I have a limited space, but I'm going to try to get it done here. Okay? Alright, here we go, guys. So we're going to work out question 4. So once again, we are looking for an unknown side. Check. We are in fact working with a right angle triangle. That's also checked. And have we been provided with two sides? Check, check. So therefore we know Pythagorean theorem is our formula. Now in this case, as I've been reiterating right throughout the video, that C represents the hypotenuse, not the unknown side, the hypotenuse. So don't be fooled by the first two examples because I made C my unknown side. That was in fact because C was in fact, or X was in fact the unknown side in the first two examples. But in this case here, C is going to be 13 squared. Now A and B, you have a choice as it relates to what you want to make A or B. So I'm going to make A be the x squared, and I'm going to allow B to become the 5 squared. So I have 169 here, and you can definitely confirm that, guys. 13 squared is 169, and that's equal to x squared plus 25. And just like the example that we had on the previous page, we would transpose the 25. So we're going to end up with 169, take away 25. That's going to be equivalent to x squared. So subtracting these two, we'll find that the result here is 144. And that's going to be equal to x squared. So x then is going to be equal to, pardon me, I've already taken the square root of x squared, so that's x. And the square root of 144, it works out that x is in fact 12 centimeter. And this is actually another example here that's a part of our Pythagorean triplets. All right, in future tutorials I'll show you what the Pythagorean triplets are, or I'll at least add it to one of my videos coming up. Now do look out for part 2, where we're going to be looking at some applied questions. This is just examples of how to apply the Pythagorean formula, but there are more questions that requires critical thinking, logical thinking, how to use the Pythagorean theorem to get information that is needed to find an unknown side. All right, so look out for that video. But in order for you to know when that video comes up, you have to be subscribed, you have to turn on the bell, and if you've gotten some sort of value from this video, do not forget to smash the like button and share this out to your other friends. All right, so I'll see you in another tutorial video. I hope this was of some value to you. Take care, and I'll see you next time from the Apex, from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor. Continue practicing to become more consistent. Take care.